Good morning. Next is action of heat on dicarboxylic acid. Action of heat on dicarboxylic acid. Planck's rule. Planck's rule. It's very important. Action of heat on dicarboxylic acid. So here we discuss only about dicarboxylic acid. That means carboxylic acids containing two COH group. So that type of acid, what will happen when we heat it, that only we are discussing. And the rule following is known as Planck's rule. First one, dicarboxylic acid containing 0 or 1 intervening carbon atom. Okay. Dicarboxylic, first we discuss dicarboxylic acid containing 0 or 1 intervening carbon atom. What do you mean by 0 or 1 intervening carbon atom? Look at here. Example is we are taking oxalic acid. The formula of oxalic acid is COH. This is oxalic acid. You can see that in between these two COH group there is no carbon atom. We can see that COH, then COH. That means this is oxalic acid, and you can say this oxalic acid is having 0 intervening carbon atom, or this you can call it as a 1,2 dicarboxylic acid. What is this one? 1,2 dicarboxylic acid. 1,2 dicarboxylic acid. Okay. So and this is the carboxylic acid or dicarboxylic acid with the 0 intervening carbon atom. Now what is that? A dicarboxylic acid containing 0 or 1 intervening carbon atom. What do you mean by 1 intervening carbon atom? Look at here, COH, and here it is CH2, and here again COH. Okay, this is a dicarboxylic acid having 1 intervening carbon atom. That means between these two COH group there is a carbon. This is what is called dicarboxylic acid with 1 intervening carbon atom, and this is the dicarboxylic acid with 0 intervening carbon atom. This type of dicarboxylic acid we are heating. Then what is the product? Look at it here. So first we take. First we are discussing with a 0 or 1 intervening carbon atom. In this case, when we heated at 300 degrees Celsius, or heated in presence of acetic anhydride, or when we heated at 300 degrees Celsius, or distill in the presence of acetic anhydride, the dicarboxylic acid containing 0 or 1 intervening carbon atom will give monocarboxylic acid. Carboxylic acid with the elimination of 1 mole of carbon dioxide. So look at it here. Dicarboxylic acid containing 0 or 1 intervening carbon atom when heated alone at 300 degrees Celsius, or distilled in the presence of acetic anhydride, will eliminate a molecule of carbon dioxide and it will change into a monocarboxylic acid. So look at here. This is the Planck's rule regarding dicarboxylic acid containing 0 or 1 intervening carbon atom. So let us take the example. First, dicarboxylic acid with 0 intervening carbon atom. That means oxalic acid when heated at 300 degrees Celsius, or distilled with acetic anhydride, anhydride, what will happen? Will eliminate a molecule of carbon dioxide. CO2 is eliminating, and what will happen? Then what we get? HCOH. We get monocarboxylic acid, that is a formic acid, plus what will be eliminated? Carbon dioxide. Now, if you take dicarboxylic acid with one intervening carbon atom, that means this is malonic acid. Okay, again the same reaction condition, 300 degrees Celsius, acetic anhydride, okay, acetic anhydride, what is happening? Again the same thing, one molecule of carbon dioxide is eliminating, then what is that? H and CH2, this will join together, CH3COH, we get CH3COH, plus what will be eliminated? Carbon dioxide. This is the Planck's rule for 0 or 1 intervening carbon atom. Okay, so here we are getting a dicarboxylic acid is converting to monocarboxylic acid. Here you can see that there are two COH group and it is changing to a monocarboxylic acid, that means carboxylic acid containing one COH group. Okay, here also you can see that the CO2 group is eliminated, then H and CH2, CH3, COH will change into acetic acid. This is a monocarboxylic acid. So this is the first case. Now second case. Second one, dicarboxylic acids. Dicarboxylic acid containing. So 0 and 1 is over, containing 2 or 3 intervening carbon atom. Okay, if the dicarboxylic acid is containing 2 or 3 intervening carbon atom, that type of dicarboxylic acid, when heated at 300 degrees Celsius or distilled with acetic anhydride, will undergo dehydration, and it will change into cyclic anhydride, So what will happen on heated? So this is the second case, dicarboxylic acid containing 2 or 3 intervening carbon atom. That type of dicarboxylic acid, when heated alone at 300 degrees Celsius or distilled with acetic anhydride will undergo dehydration. That means will undergo elimination of water molecule. That is what is called dehydration. The first case, elimination of carbon dioxide. In the second case, elimination of water molecule, dehydration, and will give cyclic anhydride. This is the Planck's rule for dicarboxylic acid containing 2 or 3 intervening carbon atom. When heated or distilled with acetic acid will give cyclic anhydride. Let us go through examples with the 2 or 3 intervening carbon atom. Look at here, COH. Here it is CH2. Here it is CH2. Here it is COH. Correct? How many intervening carbon atoms are there? 1, 2, 2 intervening carbon atom are there. Okay, this acid is succinic acid. This type of acid we can take, or 3 intervening carbon atom. Look at it here, COH, then CH2, then here it is CH2, here it is CH2, here it is COH. This type of acid. Here you can see that 2 intervening carbon atom, here it is 3 intervening carbon atom. This type of dicarboxylic acid on heating, what will happen? To get it here. So first let us take dicarboxylic acid with 2 intervening carbon atoms, CH2. Here it is CH2, COOH, succinic acid when heated at 300 degrees Celsius or distilled with acetic anhydride. What will happen? Undergo dehydration. That means water molecule H2O will be eliminated. So what we get? We get CH2 here you can see that CO, and of course O is there, and here it is CH2, and here it is CO. Then one oxygen is there. Here you can see that this is anhydride. This is anhydride. So look at here, H2O. You can take H from here and OH from here, or you can take H from here and OH from here. Anyway, you get CO, CH2, CO. There is extra one oxygen, then it will form a cyclic compound, cyclic anhydride. Okay, plus what will be eliminated? Plus H2O plus H2O. Or if you take another acid, you can see that COH, and here is also COH. Which acid is this one? Phthalic acid. This is phthalic acid. How many intervening carbon atom? One. Here is one carbon atom. Here is another carbon atom. There are two intervening carbon atoms. This is phthalic acid. So again, the same reaction condition, heated at 300 degrees Celsius. So this is with the acetic anhydride. Again, you can see that H2O will be eliminated, and we get phthalic anhydride. It will be like this, CO, here it is. Actually, when you write CO, what is the actual structure? Here it is like this, CO, and here it is. This is the actual structure of CO. So you get the phthalic anhydride. And another acid you can take is CH-COOH. Here it is double bond CH-COOH. This is malic acid. Malic acid. This malic acid. This is phthalic acid. Malic acid, you can see that there are two intervening carbon atoms. Again, the same. H and OH will be eliminated, and the reaction condition is same. And what we get, CH, double bond CH, here it is CO, it is CO, then there is oxygen. Okay, malic anhydride we get. Okay, one example with three intervening carbon atom. Okay, three intervening carbon atom. That means COH, CH2, COH. Okay, there are three intervening carbon atom. Again, heated at 300 degrees Celsius, or distilled with the acetic anhydride. H2O will be eliminated. What we get? What is that? CH2, CO, here it is CH2, here it is CH2, here it is CO, then the other oxygen. Okay, we get anhydride. Okay, this type of acid, or you can call it as what is this is dicarboxylic acid with the three intervening carbon atom, or you can call it as 1, 2, 3, 4, 5. Where are the COH group? 1 and 5. 1, 5. This is 1,5-dicarboxylic acid. 1,5-dicarboxylic acid. 1,5-dicarboxylic acid, because the carboxyl group is at the starting 1, 2, 3, 4, and 5. 1 and 5. 1,5-dicarboxylic acid. If there are two intervening carbon atoms, then it is known as 1, 2, 3, 4. Then what is that? 1,4-dicarboxylic acid. Okay, dicarboxylic acid with two intervening carbon atoms, that is known as 1,4-dicarboxylic acid, and dicarboxylic acid with the three intervening carbon atoms, what is that? 1,5-dicarboxylic acid. That also you keep it in mind. Okay, then third case. Now, first case dicarboxylic acid with 0 or 1 intervening carbon atom. Second case 2 or 3 intervening carbon atom, and third case dicarboxylic acids with dicarboxylic acid with 3 or 4 intervening carbon atom. Okay, this type of dicarboxylic acid, that means dicarboxylic acid with 3 or 4 intervening carbon atom, on heating at 300 degrees Celsius, or distilled with acetic anhydride, will undergo decarbokylation. That means will undergo the elimination of carbon dioxide, decarbokylation, and dehydration. That means in decarbonyl minus CO2 is eliminating, and at the same time minus H2O is also eliminating. Will undergo decarbokylation and dehydration to give cyclic ketone, okay. So once again I repeat, 0 or 1 intervening carbon atom will undergo decarboxylation, that means elimination of carbon dioxide only, then will give monocarboxylic acid. In the second case, 2 or 3 intervening carbon atom will undergo dehydration, that means elimination of water molecule only, then will give cyclic anhydride. In the third case, you can see that both carbon dioxide and water molecule is eliminating, and what we get cyclic ketone, ketone. So let us go through some example. This is the third blank rule, that means dicarboxylic acid containing 3 or 4 intervening carbon atom. So look at it here, COH, 4 or 5 intervening carbon atom. Okay, so you can see that COH, CH2, 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 COH. How many intervening carbon atom? 1, 2, 3, 4. Okay, this acid is adipic acid, or adipic acid. What type of acid is this one? 1, 2, 3, 4, 5, 6. What is that? 1,6 dicarboxylic acid. 1,6 dicarboxylic acid. 1,6 dicarboxylic acid. Okay, 1,6 dicarboxylic acid when heated at 300 degrees Celsius or distilled with acetic anhydride, distilled with acetic anhydride, what will happen? Will eliminate, will undergo decarboxylation. One molecule of carbon dioxide will be eliminated and one molecule of H2O. Both will be eliminated, carbon dioxide and water. Then what we will get? Look at here. Here you can see that CH2. Then this CH2, and here it is CH2, and here it is CH2, and the remaining you can see that CO group is there. That means this CO group will come between here. Here it is CO, C double bond, or this is a ketone, cyclic ketone. Okay, so look at here, CH2, 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 CH2. This CO group that will join here in between these two. This also join here. You get a cyclic ketone. This is CO group, cyclic ketone, plus what will be formed? CO2 group will be eliminated, plus dehydration means plus H2O. This is what is happening in the case of dicarboxylic acid with 4 or 5 intervening carbon atom, and this is the Planck's rule for this type of dicarboxylic acid. Now if you take 5 intervening, this is 4 intervening. Now if you take 5 intervening carbon atom, what is that? COH. Here also yes, CH2. Here it is CH2, CH2, COH. Okay, when heated, again the same condition. When heated, okay, when heated, what will eliminate? CO2 will be eliminated and H2O will be eliminated, and what we get? We get CH2, CH2, and here it is CH2, here it is CH2, here it is CH2, and here of course it will change into a cyclic ketone. Okay, so this is the Planck's rule for 3 different cases, and when you combine all these rules together, you can write Planck's rule. So what do you mean by Planck's rule? In a simple way, we can say that when heated alone at 300 degrees Celsius or distilled with acetic anhydride, dicarboxylic acid with 0 or 1 intervening carbon atom will undergo decarboxylation and will give monocarboxylic acid. Dicarboxylic acid with 2 or 3 intervening carbon atom will undergo dehydration and will give cyclic anhydride. Dicarboxylic acid with 4 or 5 intervening carbon atom, 4 or 5 intervening carbon atom will undergo both decarboxylation and dehydration and will give cyclic ketone. This is what is Planck's rule, and thank you. We'll continue in the next class.